Hello everybody, this is Cameron Snow, and we're going to be continuing our video series on geological risking for exploration. And in this video, we're going to talk about the statistics involved in geological risking. To get started, I want to review the basic idea behind risking again. So when we do risking, we identify the key components of the hydrocarbon system. What's the structure, trap, what's the seal, is our reservoir present and of sufficient quality, you know, is our source rock present, mature, and is there a migration pathway? So, those are our core components in the hydrocarbon system. And for each of these, if you remember what we discussed, we assign a probability. What is the probability of the structure being present? In this case, I've said there's an 85% chance. What's the probability of there being sufficient seal? Okay, there's a 90% chance in my estimation for this particular prospect. And you do this for each of the components, and then you roll those up to get an overall piece of G, or probability of geological success. Now, there is a whole body of literature out there to how we assign uh, the correct risk here. We're going to cover that in subsequent videos. In this particular lesson, we are going to be looking just at a review of the statistical terms around probability. So that way you'll have a bit of a refresher when we dive into how we assign the probability. Okay, so let's dive into some very basic statistics here. And for those of you who are already familiar with statistics, if you want, you can skip over this video and you'll probably be fine going forward. But for those of you who want a little bit of review, let's take 5 minutes out of our day just to refresh ourselves. So we're going to cover two basic concepts. The first concept is marginal probability. This is the probability of an event occurring. So uh, and we're doing this without any other conditions being applied. And so, for example, we use marginal probability in risking to say what is the probability of the trap being present, or what's the probability of the source rock being present and mature. That's an example of marginal probability. We are not basing that on any other risk, and we're looking at it in isolation. So that is marginal probability. Now, where do we see this in our day-to-day lives? Well, I like to play a lot of dice games with my kids. And when you play a lot of dice games, you have to, build up some intuition about the probability of a given outcome. So, for example, what are the odds of rolling a given number on a six-sided dice? So what's the probability that you roll a 4? Okay, well, six-sided dice, only one side has 4 dots, so it's a 1 out of 6 chance. So, very simple, can be very intuitive in a way when you apply it to situations that you're familiar with. What are the odds of drawing a red card from a deck of cards? Well, standard, 52 card deck. Half the cards are red, half the cards are black. That means the probability of drawing a red card is 1 out of 2. It's 50% chance. Okay, what are the odds of drawing a 6 from a deck of cards? Well, once again, there are 4 sixes, 52 cards. That, is 4 out of 52, or 1 out of 13 chance. So that's your odds of drawing a 6. What about the odds of drawing a red 6? Well, there's 2 red 6s, so you have a 2 out of 52 chance, or 1 out of 26. That's marginal probability, and we see marginal probability all around us when we play games. So, that is where a lot of people get their understanding of probability, even if it's intuitive and not explicit. And if you look at high level, gaming for things like poker, understanding these probabilities is critical. Now, let's add one little piece of complexity here, and that next step of complexity is what we call joint probability. So what's the probability of two or more events occurring? What's the probability of A and B occurring? Um, so once again, let's go back to one of my favorite examples, which are dice. So what's the probability of rolling a pair of fours on a six-sided dice? And this is, using a simultaneous roll, so you're rolling both dice at once. And when we think about this, the probability of, the first dice being a 4 is, 1 out of 6. The probability of the second dice being a 4 is 1 out of 6. So the probability of A and B occurring is the product of those, so 1 out of 36. So given 2 dice, you have about a just under a 3% chance of success. One of my favorite games is Yahtzee, and so, if you've got, if you've got 3 fours and you've got 1 roll left and you've got those 2 dice, what's the chance that you're going to get a Yahtzee on that last roll? Well, you've got a 1 in 36 chance. So there's a basic example for you. Another example, what are the odds of drawing a red 6 from a deck of cards? So the probability of it being red and the probability of it being a 6. Now, we're only doing one draw here. So, we can, we could view this as a marginal probability if we wanted to view it that way, as we did in the previous one, or we could view it as joint probability. And either way, we arrive at the same answer. So, we could say, the probability of it being red is, 1 out of 2, and the probability of it being a 6 is 1 out of 13. And so those combine to be 1 out of 26, or we could view it as marginal probability. So there is some overlap between the two. But if you understand these two basic concepts that we have covered, you will be able to understand all the statistics that you need to know for doing the type of risk assessment that we see here. That is, you will assign marginal probabilities here, and you will look at the joint probability, or the product of these here. And so those two simple concepts are all you need to look at a single exploration prospect and assign risk. Now, once we start looking at a portfolio and how we may drill multiple opportunities, then we'll start to look at something more complex, which is conditional probability. But for the time being, it's just this marginal and joint probability that you need to understand. All right, I hope this was useful to you. We are going to next look at how we can actually go about putting this probability value on there.